The problem is using the equation for gravity and motion of the star to predict the mass of the black hole. First, we created a code to represent the star's motion, then we analyzed the star's motion to find the net force on the star for all points of the dataset. I also assumed that the net force on the system is due solely to the gravitational force of the black hole. Using the results of your analysis, I estimated the mass of the black hole. The models relevant to the system include the momentum principle, the formula for the force of gravity, the curving motion and track of the star, and the position update formula. Here's the code that I created for this lab. So here's my model with the code. I'm about to run it. So there's my model with the new data, and there is the print results. After looking at the information given by the computed model, I use r squared and the net force to plug into the equation for the gravitational force. I also use the mass of the star and the gravitational constant 6.7 e to the negative 11th. I compared this value and I discovered for the black hole's gravity, which I found to be 1.98 e to the 31st, to the value that I discovered in the class lab, and it was the same value. The model fits the data well because it does curve in the rotation, but it does not go in a full orbit of 24 days, but rather 3.99 days. I think the first model done in the lab successfully shows the data better than this model. This lab has given me a visual example of the force of gravity and how to represent the gravitational force of the black hole on the star. Also, it showed me how to use the gravitational formula G m1 m2 divided by r magnitude of r squared